Hello everyone. In today's class, we will be doing question 12 and 13 of Cbse class 11, chapter 3, motion in a straight line. So on to the first question. A ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between t is equal to 0 to t is equal to 12. Okay. So it's dropped from a height. So the ball starts from an initial height from an initial point and the height is 90 meters. Okay, then they told at each collision with the floor, so it bounces up once, it collides and then it bounces up and then it goes down again. And then from this we can say that initial velocity u is equal to 0 because it starts from one point, and the acceleration will be 9.8 per second square, the acceleration of gravity. Then h is 90, which is given. Now we can use the equation of motion to find out velocity. So v square is equal to u square plus 2as. So v square is equal to 0 square plus 2 into 9.8 into 90. So v is equal to root of 2 into 9.8 into 90. So v, for solving this, we'll get 42 meter per second. So we got that velocity is equal to 42. Now according to the question, at each collision with the floor, the ball loses 1/10 of its speed. We know that the velocity is 42 meter per second. Now with equation of motion, we can find the time again. So we can use s is equal to ut plus half et square, or here h is equal to ut plus 1 by 2 gt square. Height is 90. Initial velocity is 0. Time we can write as t plus 1 by 2 into acceleration due to gravity 9.8 into t again. So we can write from this, if you solve, we can write t is equal to root of 2 into 90 divided by 9.8. So 30 divided by 7. So it will become 4.2 second. That's the time. Now, when we got that u, the velocity is 42 meter per second. And then we got time as 4.2 second. So after striking, because the ball, once it falls down, it strikes the ground and it loses 1/10 of its velocity. So velocity of the rebound, that we can take it as v2, right? So we'll take that as v minus v by 10, original velocity minus 1 by 10th of the velocity. So that is 9v by 10. So 9 divided by 10 into 42. So that is 37.8 meter per second. That's after first rebounds. Then the ball reaches a height after the first rebounds. We can write that. We can take that height as h dash. Now we have to find time taken. Again, after the first rebounds, how long does it take? Okay, so for that again v square is equal to u square plus 2as. For that 0 is equal to 37.8 whole square plus 2 into 9.8 into h dash. So here h dash is equal to 37.8 into 37.8 divided by 2 into 9.8. Solving this we get 72.9 meter. That's the height it reaches after the first rebounds. Then the time taken for this rebounds to take place. We can write T2 is equal to root of 2h by g. That's root of 2 into 72.9 divided by acceleration due to gravity 9.8. Solving this we get 3.8. Then u is 37.8 and t is equal to 3.8. Now for the total time taken, we have to do 3.8 plus 4.2. We can get 8. Then the ball, it takes again after the first collision it takes 4.2 seconds to fall, and then after the second collision it takes 3.8 seconds to fall. Then at time of descent, the time at time of descent, time that will be equal to time of ascent. And for this, for the time of 3.8 seconds, it take the velocity after the impact will be 37.8. So velocity of the ball after striking the floor is 37.8. Wait, velocity after striking floor is equal to 37.8 minus 37.8 divided by 10. So that is, solving this we get 34.02 meter per second. It's the same thing as here. Whatever we did here, we are just repeating. This is for the first collision. Whatever we are doing here is for the second collision. Because it loses 1/10 of its velocity. With reduction of velocity, the time it takes to reach the ground will also reduce. Therefore, with reduction of velocity, time will also reduce. Then the total time for upward motion that is equal to 4.2 plus 3.8 plus 3.8, that's 11.9. Solving that we get 11.9. Okay, we'll take that as 12 seconds. Now to plot the graph, it's fairly simple. Here point. E second, this will be speed, this will be meter per second. Now for this we have to take 4.28 8.1 and here 11.9. and 42, 37.8, 34. So this is the initial point from height 90, that goes, speed will be 34, and then it comes down again to 37.8, then it strikes the floor at 8.1 seconds, and it goes up again. This is for the time intervals. Yeah. So that's the first question. Now, on to the 13th question. Explain clearly with examples the distinction between magnitude of displacement over an interval of time and the total length of path covered by a particle over the same interval. Magnitude of displacement. First of all, displacement is the shortest distance between any 2 points. If we take A and B, if a car travels from A to B, then the shortest distance will be the displacement. Okay, let's take a triangle. If let's name this triangle as A, B, and C. So a car starts from A, goes to B, and goes to C. Distance will be the total distance covered, the path length. That's AB plus BC. Displacement is the shortest distance. So instead of taking AB plus BC, we'll take AC. That's the only difference. Then magnitude of average velocity over an interval of time and the average speed of the same interval. Magnitude of average velocity, that is displacement by time. But average speed is distance by time. That's the difference. So in one-dimensional motion, magnitude of average velocity is equal to or less than average speed. That's it. These two questions, question 12 and 13 of NCERT physics. I'll see you in the next class.